Your body moves because an idea turns into electricity. Seriously. I think raise my hand, and my brain launches a tiny electrical pulse down a motor neuron. That signal races along the wire-like axon, hits the end, and boom, packets of a chemical messenger, acetylcholine, pop into the gap to the muscle. Muscle cells are listening. They've got receptors that catch that message and open floodgates for sodium. Now the muscle cell fires its own electrical wave, zipping along the surface and diving into little tunnels called T-tubules. That wave tells storage closets inside, sarcoplasmic reticulum, release the calcium. Calcium is the key that unlocks movement. It snaps onto troponin, shoving tropomyosin out of the way so myosin heads can grab actin. Think tiny rowing oars lining up in a stadium. With ATP as the fuel, those myosin heads pull, let go, recock, and pull again. Millions of these cross bridges cycle, and the sarcomere, the basic unit, shortens. Stack billions of sarcomeres, and a whole muscle fiber shortens. Bundle fibers into a muscle, tug on a tendon, and the bone moves. I don't move with one giant switch. I use motor units, one neuron plus the fibers it controls. Light task? I recruit a few small, precise units. Heavy lift? I stack in bigger units and fire them faster. Muscles work in pairs. Biceps flex, triceps extend. While one contracts, the other relaxes, coordinated by the nervous system so I don't fight myself. Sensors. Muscle spindles. Golgi tendon organs report stretch and tension back to the spinal cord and brain, adjusting on the fly. That's why I don't drop a cup when someone adds water. Energy-wise, I start with stored ATP, then creatine phosphate for a quick boost, then shift to sugar and fats with oxygen for the long game. Thought to nerve, nerve to muscle, calcium to cross bridges, pull to motion. That's the flow behind every blink, stride, and high five.